Alright, this one's a doozy, so my walkthrough is extremely thorough because this is for people that really don't know what they're doing. Sorry about my voice, it feels kind of awful. But besides that, this may be too thorough for some people. So if you just want a quick answer, you know generally how you do it. There's a lot of other resources out there, including the homework solutions from the Susanna person. But if you really don't know what you're doing, you want to understand from like very fundamental level, here we go, 13 pages. Alright, so first we need to understand how the particle will travel. This is just a shitty sketch I have. You can ignore the black, green, purple. That's just my labeling because I did my work on a whiteboard in different colors. So there is a magnetic field in each of the boxes. And you should know, because this is a general concept, that it will travel in a circle in here. It will experience centripetal force. If you don't know that, you need to review your lectures, because yeah, that's just a general concept. In between the gap, it will speed up. We're told this. But there is no magnetic field, no fancy force here. And then here, in the second region, it does the exact same thing. So, we ultimately want to find time. So let's look at region 1. I'm going to split this into 3 parts. Region 1, the gap between, and region 2. Region 2 is done the exact same way as region 1. So here is my work for region 1. I will have this document linked, so if you just want to look at my work, go ahead. My work is kind of messy and hard to understand, which is why I have this in this little video method. So, let's think about this. We know this particle will get centripetal acceleration, and it will travel in a circle. Well, a half a circle. So to find the time it spends in there, we ultimately want to know the period. Well, half of the period, yes, because it's half a circle. So, we want to find period, or t. And note that period equals 2 pi divided by angular velocity. This is just a definition. I mean, you can prove it. It's from Physics 1. I put in a little note here if you want to read why this is true. But this should make sense to you. And if not, here's a small explanation. So, to find period, we need angular velocity. But we don't know angular velocity. So we need to find angular velocity with the information that we have. So we know the kinetic energy. This was given to us in the problem, right here. We know it's its charge because it's an electron. And that's a constant charge. And we know the magnetic field in Teslas, right here. So let's think about this. We want the angular velocity of something going in a circle. This should scream out to you the formula for centripetal acceleration, or centripetal force, which is force equals mv squared divided by r. You should know this. And, well, we want angular velocity, but luckily for us, angular velocity and velocity are related directly by r. So we can find velocity very easily, and then we can find r, and then we will know angular velocity, because force, as you'll find out, will be very easy to solve. So let's first try to find velocity. So do remember that kinetic energy equals 1/2 mv squared. We know what m is. It's just the weight of the electron. I think is 911 times 10 to the negative 31. I think so. I'm not 100% sure, but it's probably it. Just go look it up. In this case, we're given Ke. Note that it's Ke, a voltage. So we need to multiply our K by E, charge electron, which is just this, something like that. So then we plug in everything that we know. So we plug in this 4.3 K, because this was given, times by E, charge of E, is given 1/2 m, which is just the mass of electron. This number should be the same for all of us. And then v squared. And then v is this. If you want to see my work more thoroughly, just look at the little whiteboard work above. So great. Now we have the velocity. So now we are still missing force and radius. And the reason why we're solving this is because we want the radius so we can take our velocity to find our angular velocity. So to find radius, we need force. Well, luckily, force is pretty easy to find. This is probably the most general formula that's first came from physics 2 that you'll have to know, is that force in a magnetic field equals charge times velocity times magnetic field in Teslas. Teslas is this number right here. So let's be honest, if most people that know how to solve this when they're working on it would probably start here, and they'll probably be able to skip all the beginning. But if you don't know, you will eventually reach this point. So either way, so force equals Q, just the charge of the electron, times by your velocity that you just found, which is nice, and then your magnetic field in Teslas. And this will give you your force. Great. Now we have force. We know mass. We know velocity. So now we can find R using our sorry, this is the angular momentum, angular force, centripetal force equation. So you plug in your force that you know, you plug in your mass that you know, you plug in your speed that you know, and then you find R. Great. Now we have radius. We can find angular velocity. Once we have angular velocity, we can find period. So to find angular velocity, you just take your velocity and divide it by your radius, and you get angular velocity. And then from your angular velocity, you can use period equals 2 pi divided by angular velocity to find your period. And that's how long it takes to travel in a circle. But it travels in a half a circle, so we use half of the number. If you do look at my whiteboard work, for what I used to find angular velocity, I did it in a really stupid way, because I did force, but it still works. I did force equals mass times angular velocity squared times r, and I proved why this works on my thing, but you don't have to do that to find angular velocity. Just take your velocity multiplied by r. It's so much easier. Did not realize that until I was working through this. Hey, you always learn anything. Okay, so this is your time from the first region. Make sure you note this down, and make sure you really understand this process, because for the second region, you do a very similar thing. But let's now look at the little gap. So now we're looking at this part. Okay, so here's the work for it. Either way, so the key realization here, this is actually mostly a physics 1 concept, is that the potential difference in voltage is really just a decrease in potential energy. Just think of it like that. And recall conservation of energy. Kinetic energy plus potential energy doesn't change. So when you go across the gap, the potential difference goes from 2,100 volts. This is just given to you right here. This is probably different for you. And it goes down to 0. So the potential goes down by that much. So this means the kinetic rises by that much. So since Ke was given in Ke volts, we can just add them together to get our new Ke. So we take our 4.3 KeV from here, and then add 2,100, your voltage here, and this gives you your new Ke at the end. Why are we doing this? Because we need to know the final speed. Why do we need to know the final speed? Well, you need to know the speed when it goes into region 2. Yeah, because for the same reason why we need to know the speed for region 1. Because we need to find angular velocity, and you need velocity to do that. So please, please, please know this. I'm not going to explain it, but you should most likely know this. But if not, you can just read that. So we have a new kinetic energy, and we need to find the time it takes to cross the gap. Luckily for us, there's no magnetic field or whatever crap to consider. So think, we have an initial speed. We know the initial speed. It was the speed that was in region 1, because it left region 1 with the same speed that it was in region 1, because it's centripetal acceleration. Its speed doesn't change. We know it speeds up to some final speed. We're literally told that, but even if you weren't told that, you would know that. Speed increases uniformly. This is pretty important, but you probably already know it's uniformly. And we want time. This should scream kinematics to you. Most notably, we have final velocity, initial velocity, and we know distance, and we want time. Well, distance is given to you, no problem. So, I use this equation. Most of you probably looked at Susanna's work. She did something different. I don't understand it. This makes sense to me. And this works because we have uniform acceleration. That's the basis for kinematics. So, we can very easily find time here once we find final velocity. Final velocity, we can just use our new kinetic energy at the end, which was 6,400 in my case, and plug it into 1/2 mv squared. We know what m is. It's just the mass of electron. We know Ke nu, the new one, because we solved it before, and then we can find velocity squared. So this is my new velocity. So now we have my new velocity. We can take that new velocity, add it to our old one, divided by 2, blah, 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 and figure out what the hell our time is. So this is our time across the gap. This should be your biggest number. At least it was for mine. Maybe your numbers are super, super different, but moving on. Part 3. It's almost the exact same as part 1. So I only left like my picture work here. So it's done in the same way, and your velocity you're using would be your v final, because that's the speed it enters. The speed it enters region 2. So you use your new higher speed. Your magnetic field is different. You have a different Tesla. And yeah. So then you do the exact same method as region 1. You should get a new time. You add those times up, and that'll give you your final time. Alright.